My fault. All right, so a detour, slope and the geometry of lines, right? That's what we're getting into today. So we saw in the last section how geometry can be helpful in solving a linear equation in two variables. In particular, using the fact that 2 points determine a line, we were able to find all solutions of a linear equation in two variables as a graph. So just by knowing any two different solutions. In this section, we continue the theme of how geometry can help us study linear equations in two variables. After defining the slope of a line, we will show how we can use this concept to develop another method for graphing the solutions to such equations. All right. So we will also show how this concept allows us to write an equation for a line in the XY plane. What's up, man? So the slope will give a way to measure a line. It will be a single number that is designed to measure the steepness of the line, right? So consider, for example, the lines shown in this figure below, right? Line A, let me see if I could get y'all that image as I'm talking. 1 second. Ooh, wrong one. Get y'all that real quick. Ooh, here we go. So this is what we're talking about right here. I'll just make that a little bit bigger so y'all can catch it. All right. So line A is steeper than line B, right? So imagine yourself riding a bicycle up two hills represented by these lines, right? This is A right here, right? Um, it will be harder to pedal up line A, the first one, than line B, right? So we will want to assign a larger number as the slope of line A than the slope of line B. Line C is not steep at all. It is flat, right? So we will want to assign a slope of 0 to this line, right? Line D appears to be about as steep as line A, but in a different direction, right? So remember, we read this from left to right the same way that we read a book, right? So while D is slanted downwards, we will assign a positive number as the slopes for line A and B, but a negative number for the slope of line D, right? So vertical lines are special in that they do not have a slope, right? So, for example, don't try to ride your bike down a vertical cliff, all right? That's not going to be too good. But here we go. These are like the slope of lines, right? This would be a negative slope going down, positive slope going up, positive, and this is 0. All right. Questions on this? We good? We all know about slopes? All right, cool, cool, cool. All right. Got a little picture up in here, right? So how do we make this measurement called slope? It turns out then an effective way to assign a number that matches exactly with our expectations from the previous paragraph is to define the slope as the ratio, A, of the vertical change in the distance between 2 points on the line to the horizontal change in distance between the same 2 points with the underlying with understanding, excuse me, that a change from the upper to the lower, going from left to right, will be negative. All right. So long story short, I have a line right here. I want to measure this slope, right? So the slope M is going to be the vertical line, right? Divided by the horizontal line. That's it. All right. Keep clicking the wrong thing. Where you been? I feel like I haven't seen you since last week. Got you. Got you. My fault. You were still copying? My fault. Got you. Yeah. Yeah, we gave back the test yesterday. Everybody was happy. Yeah. You get yours back. I got you. After class, I'm gonna get you. Get you. Yeah. All right. So notice that we have defined the slope without reference to a coordinate system, i.e., without the xy plane. In this case, that the line is drawn with the reference to the coordinate system, the vertical and horizontal distances in the definition of a slope can be written in terms of the coordinates of 2 points on the line with coordinates x1, y1, and x2, y2. All right. So the slope of a line in an xy plane. So the slope of a line in an xy plane passing through the points with coordinates x1, y1, and x2, y2 is given by the ratio slope is equal to y2 minus y1 over x2 minus x1. Sometimes we also write that as the change in y over the change in x. All right. And that's how you find slope. That's like two of your homeworks down right there. Is this one formula? That's the formula. Yep. Yeah. So like I posted like a week's amount of homework yesterday. So y'all could have just go and do it whenever, you know? But yeah, this is like two of your homeworks right here. This one formula. Hmm? So it should be pointed out that in this context, the notation change in y and change in x are, let's continue that idea. Oops. Hmm? Or the right triangle? Oh, this is change, right? Change in y over change in x. It means the same thing. You're just subtracting two of the numbers together, right? You subtract the two y's and then divide it by the subtraction of two x's. All right? Hold on a second. So it should be pointed out that in this context, the notation change in y over and change in x are sometimes used to represent the change in x and y respectively. So the slope can be remembered as the slope is equal to the change in y over the change in x. There you go. And this is what it means graphically, right? I have 2 points, x1, y1, x2, y2, right? There's some horizontal axis here from x1 to x2 and some vertical axis here from y2 to y1. Plug it all into the formula, right? So the slope is equal to the vertical line divided by the horizontal line, or y2 minus y1 over x2 minus x1. Questions on this? Any questions from calculator? Yeah. No questions? Everybody good? I'm pretty sure it's on your formula sheet too. All right. So in order to use the formula defining the slope, the coordinates of any 2 points on a line are needed. All right, let's try this out. Find the slope of the missing line passing of the line passing through the point coordinates 6 comma -2 and 3 comma 7. Go ahead and try it out. I don't have paper. Wish I did. Oh, you know what you could do? The print the the computer lab over there, just go in there and steal the printer paper. Yeah. You know where the bathroom is? It's right in front of the bathroom. Yeah. Yeah. Back when I was a student, that's what I used to do. I used to go in the lab, just take the printing paper, you know, and then I staple it together. No, that was my notebook. All right, I really used to take the scrap paper. So you know when people print out one sided and they made a mistake, so they throwing it away, but the back side is good. Yeah, all my homework was on stuff like that. I had advertisements after every page, just like a commercial in between all my problems, you know? Hi, how are you? Good, good. So we just trying to find the slope of this. You remember how to do this? Oh, I got you. Mhm. You just subtract them and divide them. That's it. I haven't checked, but I feel like it's on the formula sheet. So you don't gotta memorize it. Still trying to decide on exam two. I've got a couple more things to learn before then, but it should be easy though. Did you grab a single sheet
Oh, that made.
in the whole stack over there? What is what is chicken? Now you open up the printer. I know there's a whole stack inside of the printer.
Right, that got sheet going. I should have opened it, I was under it.
You under it?
Like, it was like paper.
Oh, cause you was looking for the see, think like me. That's why. I was telling you about the clean paper, you know. By the way, those who just walked in, right? Y'all know today Wednesday, right? Yeah, that mean that today pantry. Like y'all brought y'all bags for y'all groceries and stuff. Yeah, they got free groceries in Low Hall. Yeah, yeah. Like raw food, like uncooked food. Groceries, yeah. They got milk, eggs, bread, fruits, vegetables, not cut up, like whole fruits and vegetables. Uh,
You don't put this because you see how I'll get confused with this.
mm-mm. I got you. I'm gonna show you. You almost there. You almost there. Like you have the right formula, but it's just to plug it in.
No, no, I'm saying, am I writing?
Mm-mm. There should be a division.
Oh, no, I'm not
Yeah,
done. This is top.
yeah.
And then over this,
Hmm.
right? So,
I got you. So sometimes this might help, right? Before you actually execute this, give it a label, right? So let's say that I made the first point x1, y1, and I made the second point x2, y2, right? Go back to our formula. So the slope, right? So we're clear, the M means slope, is equal to y2 minus y1 over x2 minus x1.
put it back.
Yeah. Just plug it in. No, it can work if it's backwards,
No, I put it
right?
back.
It doesn't matter. It can work. Yeah. So this is the same thing too. If you wrote it like this, y1 minus y2 over x1 minus x2, you get the same answer. The working out of it would be different, but the answer would be the same, right? So let's do the first one, just because like that's what the textbook gave us, right? So y2 I said over here was 7 minus the -2, which is the y1, over the 3 minus 6. A little bit of math, boom, boom. What's 7 minus -2? 9. Very good, right? Negative is positive, blah, blah, blah. You can type this in the calculator, so no worries about that, right? What's 3 minus 6? -3. Very good, right? And then 9 divided by -3 is -3, right? So that's my answer, and that's it. You don't have to label it if you don't want to, but I like to label it and then just plug in the numbers into the formula. Mhm. You did the graph too? Nice, nice. All he wanted was a slope though. But just to prove to you guys real quick, I'm gonna flip the formula. This is y1 minus y2 over x1 minus x2. Just to show you guys, right? So y1 we said was -2 minus y2, which is 7, over x1, which is 6, minus the x2, which is 3. Do the math on this. -2 minus 7 is what is it? -9, right? Because you owe me $2 and now you owe me 7 more. So -9 over what's 6 minus 3? Okay. And then -9 divided by 3 is -3, right? So you see, it don't matter the order that you go in, right?
When you graph it, you.
Well, we didn't get there yet. But you guys know how to graph it, right? Point here, point here. Use your BCC ID, just ching, and that's it. Yeah. I'm not going for it. Now that I can't print on campus no more, that's all I use my BCC ID for, just to draw lines. Like that's it. Yeah. They took it away. And you know what made me so mad though? Well, because I graduated, that's why. But you know what made me so mad though? So every semester, like this semester, all of y'all got a printing quota, right? I don't know. I don't remember how much it is, $20, $30, whatever it is, right? But y'all all got a printing quota, right? So what that means is that y'all could go anywhere, any computer lab, y'all could print whatever y'all need to print, right? Some printers got color, like the ones in the library. Some printers are just black and white. But the point is y'all could print, right? So what happens next semester? Let's say you didn't use the money, right? They just take it back and give you a brand new set of money next semester, right? It doesn't roll over. That's what I'm trying to say. It doesn't, you know. So yeah, cause like yo, for me, yeah, y'all know I did math, right? Yeah. Like I did math, so I wasn't printing out like crazy like that. That's an English thing. So I should have printing quota left over, and I did like 4 semesters over here, right? And I ain't got nothing. Right? I got you. I got that. I got you. I got you. Yeah. Not doing color. Yo, color expensive over here. But worth it on campus though. There's y'all ever been to this store, Postnet? Oh my God. I never seen this place so expensive in my life. Postnet. Like, mm-mm-mm. If y'all need something done, go there and get it. But if you just trying to print out your homework or something, like don't go to Postnet. Like it ain't worth it. It got to be something big, like y'all trying to get something printed out, laminated or something, you know? All right. So for the sake of the reader who is seeing the slope formula in action for the first time, let's redo the previous with that, blah, blah, blah. We did that already. So we proved that, right? So we obtained the same answer, that the slope being -3, right? So this is a special case of the point that we made in the definition. The slope does not depend on which 2 points on the line are chosen. All right. And in particular, does not depend on the order that the points are used, right? Although a graph is not necessarily for the purpose of computing the slope of a line, the reader might want to plot the two given ordered pairs, 6 and -2, for example, and 3 and 7, to visualize the line passing through the corresponding points to verify that the line slants downwards going from left to right, as you would expect from a line with a negative slope. Hi. Right? So we next illustrate an example where the required information to compute the slope from the definition is not given directly. We will see shortly that there is another more effective way to approach this example. So try this example out. It says use a definition to find the slope of the line given that you have the equation 2x plus y equals 2. So without me telling y'all how to do it, try it. And then of course I'll tell you how to do it. I mean, I just did it in my head. Yeah, it was quick.
Everything is quick.
Yeah, it's like one step.
Divide.
No division. It's more simple than that.
We have to find the slope of this equation.
Minus y.
Yeah, that's it. But I give y'all a minute to try it. Hmm? Hmm? You solve for it. That's it. So I say this in the announcement earlier, but y'all could do the corrections like y'all have to before the final to get it back to me. Alright. So y'all don't gotta get it back like tomorrow or something, but just sometime before finals. Yeah. You tried the homework yet? No? The first homework is you just like plotting numbers like dots. You're just saying what is the X and the Y. That's it. And then the next homework is the slope stuff. Events happening on campus. I'm trying to think what else is happening on campus. I haven't heard anything recently. There's this lady, her name was Karen. She was here yesterday. She's like an assemblywoman. She's also like an oncology nurse at Monty at the same time.
Oncology?
Yeah, I don't know when she sleeps. Like she a nurse and she does politics. But she was here yesterday. Meeting.
You mean?
No, she was here on campus. Yeah. She graduated from BCC. I didn't even know that. It's like, wow. Now, other than that, I'm trying to think what else is happening on campus. Y'all know about pantry today. Y'all could go to pantry tomorrow also, all right? Like if y'all got cars, y'all Gucci. If not, get a wagon. Y'all be good. Um, what else is going on campus? I don't even know. This supposed to be some type of meeting. I don't know if it's today or tomorrow or something like that. Where it's supposed to be like all the students, like y'all get together and y'all get to talk to administration. Y'all can say what y'all like, don't like, and what you would change about the school kind of thing. If y'all want to go, I hear there's food. That's the only reason I'm telling y'all. Mhm. But if y'all have an opinion, that'd be dope too. You know? All right, let's talk about this. So I got 2x plus y is equal to 2. I actually did this in my head, right? All you got to do just solve for y. Subtract the 2x from over here. What you do to one side, you got to do to the other. So now you got y is equal to negative 2x plus 2. What's the slope? Exactly. So our slope, m, just to recap, that's the slope. is -2. And that's it, we're done.
But I did way more than that.
For real? Yeah, just one little subtraction, that's it.
Oh my God.
Yeah.
Thinking how to wait,
Yeah.
but then I was thinking, like,
Was too easy?
yeah.
I got you.
I was
Yeah.
thinking, I was thinking, oh, I can just find it easily by,
Mhm.
see why to the speed.
Exactly.
And then use it
Exactly. Mhm.
The slope is always
Next to the X.
the
Yeah.
X.
Yeah, next to the X. Yeah. Mm-hmm.
But I literally found the Y and found the X and then used those and plug it into the equation.
That's not bad.
Two and X up. X
That-
one.
That's not bad. I'm impressed. I'll be honest.
I feel like it's a-
Got you. Got you. An alternative method to do this. We all know how to solve for the equation, right? Find 2 points, use the formula, right?
What
That's,
happened?
yeah, that's actually not a bad way to do it either. That actually proves it. You know? Matter of fact, let's try that with this one. I'm gonna just tell y'all the process, right? Find 2 points, like we did yesterday. Use the formula. That's it. Even though y'all know what the answer is, I'm just saying. Let me see if y'all remember from yesterday though. What point am I gonna plug in for X here? Good. What about another point? Give me another point for X.
Two.
No.
Zero.
0. Good, good. Give me another one.
Negative.
Negative what?
Three.
Good. That's it. All right. There you go, your 2 points. Changing Y, changing X, done. All right. You don't need 3 points, but just letting y'all know y'all have options. All right. Man, how are you? Okay, good. So we good? That was today? Oh, well.
All right.
Hmm, that looks nice. Okay. Was checking my email, see if there's anything that jumps out I could tell y'all about, but nothing jumps out. All right, anyway, let's pick our points, right? All right. So remember what I said. We got 3, 0, -3, all right? Always the easiest thing you can do, plug in the denominator as well, let's see, as well as the opposite of denominator and 0. You can't go wrong with 0, all right? So you just plug them all into the equation you have here. So y equals 2 over 3. Let's do the first one, times 3 minus 4. Threes will cancel out. This becomes what? 2 minus 4, -2. There you go. Plug in 0. We have y equals 2 over 3 times 0 minus 4. You already know that's 0, so this is equal to -4. Last one, right? We're going to have y equals 2 over 3 times -3 minus 4. These will cancel, so this equals what? -2 minus 4, call that -6. Right? They asked us for the slope, right? Remember our slope formula? M is equal to y2 minus y1 over x2 minus x1, right? I'm gonna just use the first 2 points because those numbers are smaller, be honest with you, right? So I have -2 minus -4 over 3 minus 0, right? -2 minus -4, what's that? Hmm. So a negative and a negative is a, all right, so -2 plus 4 is, no, 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 yeah, +2, right? And what's 3 minus 0? That's the hardest one. It's 3? Okay, good, good, good. Then that's it. Right? So that's how you prove it. Questions on this? Easy, right?
How do you know,
Mhm.
which one is which?
It doesn't matter.
Oh,
It doesn't matter. For this one, I did top minus bottom. -2 minus -4, 3 minus 0.
Oh, I see.
That's
So
it.
when you get those right, you gotta put in the y, huh?
Yeah. And I could have reversed it if I wanted. I could have used the bottom one if I wanted. It'll all give you the same answer. Doesn't matter. All right. Now we're gonna take it up a notch, right? So we're going to talk about the slope-intercept form of a linear equation in two variables. So suppose that a linear equation is written in a special form, y equals mx plus b, with the variable y by itself on one side of the equation, and m, the coefficient of x, is the slope of the line. And the y-intercept has coordinate 0, comma b. So your b term is your y-intercept, okay? The special form of writing linear equations in two variables, where the variable y is written by itself on one side of the equation, is known as the slope-intercept form of the equation of a line. Since both the slope and the y coordinate of the y-intercept can be written directly from the equation. So notice, right, the equation y equals 2 over 3x minus 4 was written in slope-intercept form. The slope 2 over 3 was indeed the coefficient of x. Notice also, although we didn't mention it at the time, that the y-intercept has coordinates 0, comma negative 4, a fact that we could also read from the form of the equation. So keep in mind that the b term is the special slope-intercept form is added, so we can think of the equation as being y equals 2 over 3x plus negative 4. All right? If a linear equation in two variables is not written in slope-intercept form, then there is no way to read off the information so easily. However, by changing the form of the equation, we can take advantage of the special slope-intercept form for any equation. Okay? So long story short, no matter what jumbled up way they might give you the problem, you can always switch it around to something you know how to do and then do it. Right? You guys try this one. All right, try that out. So I want the y-intercept form of the line. Long story short, solve for y. And then I want the slope of that line. All right, let's take a look. I got 3x minus 4y is equal to 12. Long story short, I want to solve for y. So I'm going to subtract 3x from over here. I do the one side, do to the other. So I have negative 4y equals negative 3x plus 12. All right, that's fine. Negative 4, exactly. All right, everybody. So now I get y equals positive 3 over 4x minus 48. Questions on this?
You can do the other way, 12 minus 3x.
Yeah, that was the word. What's the slope here?
If I can get
3 over 4, and that's it.
I can get 48.
12 divided by 4 is 3. You're right. Oh, because I was multiplying it. Yeah, it should be 3. You're right.
Oh, let's see.
Yeah, my fault.
And
Mhm.
I
you
thought
put it minus 3 because of the sign.
No, 12 divided by negative 4.
Oh,
That's my fault.
focusing on the next.
That's my fault.
So it was a positive over this less number.
Questions on this, anybody? We good? All right. Uh-huh. More specifically, 0 comma negative 3. So now let's talk about using the slope as an aid in graphing. So in this subsection, we show how the slope gives an alternative method to the problem of graphing the solutions to a linear equation in two variables. Apart from making a table of values to find solutions, it is based on the following principle. The slope, considered as a ratio of the change in the y coordinates to the change in the x coordinates of a given point on the line, gives a way to obtain a new point on the line from a given one. Specifically, we will think of the slope as a fraction that gives instructions to move up and to the right or down and to the right, depending on whether the slope is positive or negative. So here's the question. Find 3 of the points on the line passing through the point with the coordinates negative 3, negative 2, and having slope 2. Go ahead. Are we good? So this graph has to pass through the point -3, -2, and has to have a slope of 2. So if I have y equals mx plus b, and I know what m is. This is y equals, not 2. Yeah, 2 x plus b. Plug in the x and the y. All right, so -2 equals 2 times 3 plus b. All right. My fault, -3, right? So this becomes -2 is equal to -6 plus b. Add 6 over here, right? 4 equals b, right? And that's it. Questions on this, anybody? I'm sorry? It's just an easier way of doing it. You could do it other ways.
Because of the M, oh, but M is the slope happens.
So after you find this slope, right? They said that they want 3 points. Give me some points to plug in. So give me some points to plug in because they said they want 3 points, not 3. What's underneath the 2? No, but 2 is a whole number, so what's below it? No. Yeah, not 2, 1. So that being said, give me two answers for x.
Oh, negative.
Perfect. -1, 0, and 1. Good. Plug them in, boom, 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 see what happens. So the denominator of the 2x, I mean, it's 2, right? The denominator of 2 is just 1. So that's why I'm using 1. Mhm.
Oh, the way I did it, I just did the graph. Can we do it like that? Just make it the same answer, right?
Mhm. Plugging in the -1, I have what? Why did I say minus b, plus 4? This would be +2, +4, 6. Mm-hmm. That's a 4. My 4s are messy. So that's my table of values: -1, 2, 0, 4, 1, 6. Questions on these? Anybody?
They're called linear.
Mhm.
Why don't you show me how to put that in?
I got you. Just go to y equals. I'm listening. Hmm?
Like,
Hmm?
four.
Graphing?
This name is.
Yeah. Hmm? Yeah, we spoke about that briefly. So you read it from left to right the same way you read a book.
Let me give you a graph.
All right. So graph this for me. Good. So you remember you got two ways now, right? Y'all could do 2 points. Use your BCID, there's your graph. But now you have your slope, right? So you can find the y-intercept, rise over run, good to go.
Like this?
Yeah, that's it. That's the answer.
So I
Give
count
me,
them.
but give me like 3 table values or something. So press like second and then table
Second,
at the top, yeah.
table.
And give me like 2 of those answers, 3 of those answers.
Oh, that's what you do.
That's the table. Yeah, you done good.
Take them also.
I got you.
I mean, take them back.
Too strong. One time I went to the eye doctor, they changed my prescription. I thought it was too strong. I had to go back to the original.
There's like,
Mhm.
equation, like linear equation.
Mhm.
I can put it on. Then I have the second table, you go there.
True. You could do that.
Hmm?
You can do that. That's true.
So the one that we just did, I can plug in.
Uh-huh.
Like the negative 2 equals 2, parentheses negative 2 equals b.
Mm-hmm.
I can do that.
You good. Let's make a table of values. All right.
Proceed.
Hmm?
Oh, you're going,
Yeah, I'm gonna do it. So let's say I plug in 0 for x. What's my y value? I plug in -1, right, for x. What's my y value?
zero, 3, 1, 2.
That's 2. What is that?
Oh.
Hmm?
I thought that was slow, right there. 4.
I'm picking points right now. 4.
Okay.
4, that's it. What about 1? Let's try that. No. What's that?
1 has 2.
That's 2. All right. Make it simple. You could just graph these points and call it a day. Zero, 3. Where is that? Right here, right? 0, 3. What about -1, 4? Where's that? -1 go up to 4 right here. 1, 2. Where's that?
Over 1 up.
Exactly. Make your line.
You put the arrows in there.
Yeah, I like to. So, and that's it.
Over top of right little bit, and then it helps.
Go ahead. So I take it we're good. Here, you try.
Why do that?
Hmm? Same thing. Solve for y, plug in numbers, get 2 points. Boom.
No, I'm saying.
Mhm. Mhm. Just solve for y first.
Right. Oh, yeah, maybe. Okay.
Plug in three numbers and then graph.
But I have to keep that negative. I think it cancels out, right?
Whatever's in the denominator of the with the x. So if you have a whole number,
No,
then you're using the one.
I did this, you said.
Perfect. Oh, no,
I don't keep that though,
no, no,
right?
no. Divide by negative on everything.
Hold on. Oh, this too.
Yeah.
By -2.
Like all three terms get divided by -1.
Oh, on this side, not here.
Yeah.
Oh, yeah. Okay, so we're gonna do. Oh, because it's like an invisible.
Right. Because I need that to be positive. That's the trick. It has to be positive.
Okay, so like, what if that's not negative? Like, it always has to be the opposite of whatever it is.
Yeah,
So if this was negative, it'll be positive. Like if this was
exactly.
positive, it'll be negative,
Exactly.
or whatever.
Yeah. All right, let's try this out. I'm gonna add y over here, or do the one side, do to the other. All right. I'm gonna subtract 6 from over here. I do the one side, do to the other. So what do I have? Y equals 2x minus 6. Right? You know that 2 is like 2 over 1. So you already know. Gonna make my table of values. What do I have?
Um,
Definitely 0. What else?
4 -4.
1 and then -1, right? Plug them in, tell me what you get. So 0, -6,
1 -4.
1, -4,
1 -8.
-8. Graph it now. 0, -6, 0, 1, 2, 3, 4, 5, 6. And 4, this is 1, 2, 3, 4. Sorry. This is not a clean picture, but something like this should be going on. Some line that's very, very steep should happen like that. Y'all get the idea, right? And your homework is this easy, by the way. Nothing complicated. Here, try this. Same thing, graph the solutions.
You gotta solve for the y, right?
Yep.
Totally. You know,
Mhm.
and but not. So we have this.
Good, now divide by two.
Yeah, no, I know that.
Yeah.
This is a deficit,
Mhm.
yeah.
It could be. Yeah. Decimals are just fractions. That's all they are.
Pick like -101.
Mhm. Whatever's easiest. All right, let's go over this real quick because I want to show you guys two more things before we leave. All right. So I got 3x plus 2y equals 5. I'm going to solve for y. So subtract 3x from both sides. I have 2y is equal to negative 3x plus 5. Divide everybody by 2. Right? So I have y is equal to negative 3 over 2 plus 5 over 2.
You go bring down the X.
X, I forgot about that. Yeah. I always leave X's on the street, you know? Yeah. It'd be like that. So just gonna graph this now. Wait, let me find my table of values here. So y'all already know what I'm gonna choose, right? -2, 0, and 2. Why those numbers? Because that's what the denominator is. All right. So plug in -2. This is going to be -3 over 2 times -2 plus 5 over 2. Twos will cancel. This becomes -3 over 1 plus 5 over 2 times 2 times 2. That's why we hate fractions. -6 over 2 plus 5 over 2 will give me a -1 over 2. 0, you already know, is just 5 over 2. 2 is going to give me a -3 over 1 plus 5 over 2 times 2 times 2. This is -6 over 2 plus 5 over 2. Call this -1/2. Yeah. 1 second. Negative is positive. Never mind. That's better. 10, 11 over 2. Whoops. 11 over 2. All right. I don't feel like graphing fractions, but y'all get the idea. All right. 2 points on the graph, make a line, da da da. All right, let's jump to the next another topic real quick. Because you're gonna see this on your homework, so I want to make sure we understand how to do it. It's really simple, but it needs to be talked about. All right. So finding an equation of a given line. So far, we have concentrated on the relationship between the slope and the graph of a linear equation in two variables. The sign of the slope indicates which direction the line is slanted. The magnitude of the slope measures the ratio of the vertical change to the horizontal change. And so given 1 point on the line, the slope indicates how to determine other points on the same line. All right. However, the slope concept also opens a door to answering a new kind of question. Suppose we're given a line in the XY plane described by some geometric data. How can we find an equation whose solution corresponds to the given line? What is meant by describing a line with geometric data? We will consider the following situations: a line described by 1 point on the line and the slope, a line described by 2 points on the line. We did that already, right? A line described by 1 point on the line given that is parallel to another line, and a line described by 1 point on the line given that is perpendicular to another line. All right, these new vocabulary words. So the simplest example will show that we already have tools to answer this question. So here's our next example. Find an equation for a line passing through the point with coordinates 0, -2, and having a slope of 3, right? This is not bad, right? Little y equals mx plus b, right? Our slope is 3. So y is equal to 3x plus b. Plug in the values you got right here. You have an x and you have a y, right? Just plug them in. Keep it simple, right? So this is -2 is equal to 3 times 0 plus b. Little math, boom, boom, boom. -2 is equal to b. Rewrite your equation. So you have what now? Y is equal to 3x minus 2, and that's your equation. Questions on that? So you start off with the equation of a line, y equals mx plus b. You plug in what they gave you. They gave you a slope, you plug that in. And they're going to give you another point. Plug that point in, boom, boom, boom. You solve for the b term. And that's it. All right? Do me a favor, somebody start up an attendance for me real quick. You got it? Appreciate you. Feel like we got that down packed. Just want to say one last thing before we conclude. Actually, two more things. Two more things before we conclude, right? You guys already know when you have 2 points, right? So you know how to find the slope, right? The next step after that, if you were only given 2 points, would be to take one of the points, your choice, it doesn't matter which one, to make the equation of the line like what we just did right here. Now, on your homework, they're going to throw out a vocabulary word at you. Just want to cover this real quick, right? They go to vocabulary word, right? It's called the point slope formula, right? For a linear equation of two variables. So an equation for a line with slope m passing through the point with coordinates x naught, y naught is given by y minus y naught equals m times x minus x naught, right? This is known as the point slope formula of the line. Excuse me. So it derives from the definition of a slope where we have incorporated the step of canceling the denominator into the formula. Unlike the slope-intercept form of the line, which is useful because we can read off geometric data from the equation, the point-slope formula of a line is almost exclusively used as a formula to find an equation for a line, where the values of m, x naught, and y naught are substituted to obtain an equation involving x and y. In the remaining examples, you're going to see this, right? So long story short, right? We have y minus y naught equals m times x minus x naught, right? I'm going to give you a point, right? And I'm going to give you a slope. Let's say slope is equal to 2. Let's say the point that I give you is 1 comma, I don't know, 3. I'm just making it up, right? If I was using this point slope formula, I would have what? Y, this y minus y naught equals m x minus x naught, right? So very simply, right? You're gonna plug in these values that they gave you for the knots, right? You're gonna plug in the values that they gave you for the knots. So that being said, this is gonna be what? Y minus 3 is equal to 2 times x minus 1. That's it, right? So think of this as x naught, y naught, right? There's gonna be a question that's gonna ask you to give the answer in this form. So I wanted y'all to see that, right? Before then. Two more vocabulary words real quick. Then y'all could go. After y'all sign your attendance, of course, right? Parallel lines, right? I think that's how you spell parallel, right? Parallel means that they have the same slope, right? Two lines of parallel like this, if they have the same slope,
But they never touch.
they never touch, right? Perpendicular, right? I can't spell that, but look, perpendicular looks like this, right? Perpendicular slopes are the negative reciprocal of the slope that's given, right? So perpendicular is negative reciprocal. So if I gave you the slope is equal to 2, right? What would be the perpendicular slope, right? Not just -2, it'd be -1/2, right? So negative and reciprocal, right? After that, plug it in, use one of the points, get your equation line done, right? Y'all gonna see that on the homework. Email me if y'all have any questions.
Okay.
Y'all good.
Thank you.
All right.
Can I get the that's
Yes, yes. Let me stop sharing real quick. Everybody have a good night. Da, 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 da.